Hi there, in this video we're looking at calculating the volume of spheres. We're going to use this formula where the volume of a sphere is 4/3 times pi times by the radius cubed. The easiest way to sort of derive this is using a bit of calculus, which we might do another video, but just for now you'll have to trust me that is the volume of a sphere. So let's have a quick look at an example. Let's do an example here. Where we have a sphere and it has a radius of, let's say, 6. So if we've got a sphere of radius 6, and we simply plug it into this formula, so we have the volume is equal to 4/3 times by pi times by 6 cubed. Well, 6 cubed is 216, so you got 4/3 times pi times 216. And now we need to find 4/3 of that. So 1/3 of 216. Well, a third of 210 is 70, plus the 2 from the 6 is 72. This is going to give me 72 pi. But we still need to times it by the 4, that's 1/3. We need to have the 4/3. 4 sevens are 28, 4 2s are 8. So we get 288 pi. And we'll say centimetres cubed, if that was centimetres to start. And so if given the radius, quite an easy problem. In the rest of the video I'll have a look at some slight variations on this, either where you're not given the radius or you're asked to find something slightly different to a sphere, or where in fact you need to work backwards. So still a little bit more to do, but that's the basic gist of it. Okay, so on to our second example here. So in this example we're given a sphere, but this time we're not told the radius of the sphere, we're told the diameter of the sphere. And now this is a really common way that examiners like to try and trick you out. But also in real life, it's much easier if you've got some calipers. It's much easier to measure the whole diameter of a sphere than it is to measure the radius. So actually, this is sort of more what you'll get in real life a lot of the time. But again, they'll put this in an exam to try and catch you out. So the first thing we need to do, because our formula uses the radius, we need to figure out what the radius is. Now, same with all the circles questions. If we're told the diameter is 10, then that means the radius is equal to 5 centimetres. And at this point it reduces to exactly the same as the first example. We do the volume is 4/3 times by pi times by 5 cubed. And for this one I am just going to put it into my calculator, just to make life a little bit easier for us. So 4/3. Now I'm going to put this in exactly how it turns up. So I don't know if you can see that. That's exactly what's on the board here. So if I just press equals, then that gives me 500 over 3 pi, which is what comes up. Now that might not be particularly which is what comes up. Now that on its own isn't particularly useful, so what we do is if we press the SD button just above delete, then it turns it into a decimal for us. 523.6 centimetres cubed. So if we're given the diameter instead of the radius, exactly the same as the previous one, we've just got to take that extra step to find the radius first. Brilliant. Okay, so on to our next example now. So we're told in this question that the radius, or the volume, sorry, is 400 centimetres cubed, and we're asked to find the radius. So what we do, as with any of these other working backwards problems we've looked at, we need to think, what did the person writing this question do to work out that they got 400 as their answer? Well, in this case, they probably use this formula. So they've done V is equal to 4/3 times by pi times by the radius cubed. And when they do that, they get an answer of 400. And now this is looking promising because we've got an equation. It's got one unknown in it, it's just got r, and we can solve this without a huge amount of difficulty. So let's have a quick look at how we solve this then. So when we're trying to solve an equation, we want to get the unknown, the thing we're trying to find, r, on its own. To get it on its own on this side of the equation, we need to get rid of the 4/3, we need to get rid of the pi, we need to get rid of the cubed. Now, generally speaking, I like to try and get rid of the things that are furthest away from the r first. It's just going to cause us a few less problems with cube rooting and stuff and doing that incorrectly. You can do the cube first, you just got to remember to cube root everything, whereas it's actually much easier to just get rid of these two things first. So let's get rid of this 4/3 first. Well, the opposite of timesing by 4/3 is dividing by 4/3, which is the same as timesing by the reciprocal. So I'm going to times both sides by 3/4. And now 3/4 of 400, 1/4 of 400 is 100, times by the 3 is 300. We've got rid of that 4/3. I've got pi times by r cubed. So now we're going to get rid of this pi by dividing by pi, which gives me 300 over pi. I could type that into my calculator, but I'm going to wait until the very end to type it into my calculator to reduce my rounding errors. And then finally, we want to get rid of this cubed. The opposite of cubed is cube root. So I'm going to cube root both sides. And that gives me the cube root of 300 over pi is equal to r. Now this is an exact form. There are benefits to leave it in an exact form. You don't need to round, for example. You get more accuracy. But it's quite hard to sort of intuit and see what this number is going to look like. So in this case, I think it's probably best to type it into our calculators. So again, cube root of 300 over pi. So again, I'm typing it in exactly as it turns up, cube root of 300 over pi. And the cube root button, if you're unsure, is just above the square root button. It's the yellow one. So you press shift and then square root, and you get the cube root button. And that gives you 4.57. There we go. So if we're asked to work backwards, the same as all the other problems, we think, how did they work out the answer? And then solve the resulting equation. Very nice. Okay, so on to our next example here. So now we're given a hemisphere of diameter 16, and we need to find the volume. So a hemisphere is just half a sphere. So our strategy is to pretend we've got the whole sphere, figure out the volume of what the whole sphere would be, and then once we know that volume, we can half it to get the hemisphere. So the volume of the whole sphere is going to be 4/3 times by pi times by, now what have we done here to try and catch you out? Well, again, we've given the diameter. Just be careful. We need to remember that we need to find the radius. The radius is 8. So 8 cubed. So again, I'm going to type it into our calculators to make it a little bit quicker. But I am going to leave it in exact form where I can. By 8 cubed, oh dear, 8 cubed times by pi. Gives me 2048 pi. 2048 over 3 times by pi. But remember, that's the whole sphere. So what we need to do to get the hemisphere is we need to half that. So if we divide that by 2, or just half the numerator, I get 1024 over 3 pi. Which, if I round that down, I get 1072.3 centimeters cubed. So again, a slight variation. We're given a hemisphere this time, but it's not particularly difficult. Strategy is the same as any other time. We've got part of a shape. We pretend we've got the whole shape and then take a fraction of it. Good. Okay, so on to our fifth and final example for this topic. And this one looks a little bit trickier. First of all, we sort of need to identify what the shape is, and then we need to think of a strategy of how to find the volume. So it's specifically asking for the volume of this black shell, not the whole thing. And the shell isn't even a half sphere, it's not even a quarter of a sphere. This is an eighth of a sphere. If we take a sphere, chop it in half once, twice, 3 times, and that's an eighth. So what we're going to do is we're going to do this in a few steps. We're going to find the volume of the larger sphere, and we're going to find the volume of the smaller sphere that we've removed from the centre, and we've scooped that out, and then we're going to subtract them to give me the volume of the whole shell, and then we're going to divide it by 8 to give me just the eighth that we're after. Okay, so let's have a look at the volume of the big sphere. So the volume of the big sphere, well, it's 4/3 times by pi times by the radius cubed, and we need to have a bit of a think about what the radius is. So the big sphere, again, even though it's V big, I've seen some students make this mistake before where they just say that the radius is 1, because that's 5's the little sphere, so the other number 1 must be the radius of the big sphere. But actually, remember, the radius goes to the middle, so the radius is this full length, it's this 6 centimetres. 4/3 times by 6 cubed. Okay, which again, this came from one of the previous examples, but I can't remember what the answer is, so we'll just type that into my calculator. 4/3 times by pi times by 6 cubed, 288 pi. Okay, and we'll leave it in exact form again until the very end. Now let's subtract V small, or let's find V small first of all. Exactly the same method, 4/3 times by pi times by, now the radius of the small sphere is just 5 cubed, or it's just 5, sorry, so we get 5 cubed, which again, if we type that into our calculators, gives me 500 over 3 pi. Okay, so now the volume of the whole shell is going to be equal to this take away this. Which, if we type into our calculators, we get 364 over 3 pi. And then remember, we said that this is an eighth, so the volume of the eighth, I'll just sort of draw it like that, is equal to this divided by 8. 6/4 pi divided by 8, which is equal to 91 over 6 pi, or 47.6 centimetres cubed. There we go. So much more complicated question, but if you keep your wits about you, keep your nerve, not too tricky. It all comes back to this same formula, 4/3 pi r cubed.